Hi everyone, this is Aaron. This is video 4 of a tutorial on TI-Nspire CAS calculator. In this video, I'll talk about how to solve equations, the syntax of the given operator, as well as how to use zeros. Let's get started. First of all, I'll talk about how to solve equations, and you can do that through menu 3, 1. Then you will just type in the equation you want to solve and specify the variable, which is x in this case. Then hit enter and it will tell you the solutions. You can also solve simultaneous equations by doing menu 3, 7, 1. Now you just need to pick the number of equations and specify the variables, then hit OK. Then you just type in the equations and hit enter, and it solves the two variables. It's too easy, isn't it? So now let's talk about something more interesting. If you're doing matrices, sometimes you may just have one equation, but you can solve multiple variables. And that is also possible in the CAS. For instance, you may have this equation represented in matrix form, which is like this. And so now you have one equation but two variables to solve. And the way to do that is to use this big curly bracket to enter your variables and hit enter. So now you get the exact same results. And that's about it for solving equations, but I have two more tips. So first of all, when you're multiplying variables, you must include this multiply sign. Otherwise, it's just not going to work. So for example, if I include the multiply sign, it will work as expected. However, if I don't, then bad stuff happens, because the CAS treats ax as a single variable instead of the product of a and x. Now, secondly, sometimes you might have entered something really complicated and the CAS just takes forever to calculate it. So at this point, you can choose to tell the CAS to abandon the calculation by pressing and holding this home button for 4 or 5 seconds, and then the CAS will just break. Break the calculation. Yeah, and that's it for the first section. Next, I'll move on to the syntax of the given operator, which is essentially a vertical bar. And you can find it in Control equal, and here it is. So what it does is it allows you to substitute values into variables, and it also allows you to establish constraints for equations. First, we'll see how to use it to sub values into variables. So say you have an expression like this, and you want to substitute x equals 4. So one way of doing this is to get the given operator and then type x equals 4 and hit enter. And here's your answer. Now this also works if you have multiple variables. So say you have x squared minus y squared, and you want to substitute x equals 1 and y equals 2. Now what you will do is to just quite literally type x equals 1 and y equals 2 and hit enter. And here you go. So next, I'll talk about how to use the given operator to establish constraints. So consider this trigonometric equation, sine x equals 0.5. If you just hit enter now, it'll give you the general solution. But say you only want the solution in the first quadrant, and you can use the given operator to establish this constraint. So what you would do is you would type in an inequality, which is pi over 2 greater than x greater than 0. And if you think about it, this just means that x is in the first quadrant, right? So if you hit enter now, it will give you the solution that is in the first quadrant. Yep, and that wraps up the second section of today's video. So finally, I'll talk about zeros, which is essentially a better alternative to solve in some circumstances, and I'll use these two functions for demonstration. So first up, you can find zeros in menu 3.4, and it essentially just finds the x-intercepts. So the syntax of zeros is you will type your expression first, and then you would specify the variable, which in this case is x, and then it will tell you what the x-intercepts are. So the reason that zeros is really powerful is that it returns a list, which is this thing, and it is really easy to manipulate every element of a list. So for example, if we want to find the stationary points of fx, we can do that using zeros. So remember, at the stationary points of a function, the gradient would have to be 0. So we would basically find the x-intercepts of the derivative graph of f. And here are the x-coordinates of the stationary points of f. Now, if we just pass this into our function f, what will happen is that this will essentially pass each element of the list into the function f. And since these are the x-coordinates of the stationary points, if we pass them back into f, we're going to get the y-coordinate. Yep, and here it is. So now you have solved the problem. So essentially, zeros are just useful when you need to manipulate your solutions. So another instance where zeros can be useful is when you need to convert your answers to a certain form. So see, we have this gx here. Suppose we want to find out when gx equals 0.5 for x between negative 2 pi and 2 pi, but we want the answers in degrees. So now, a really clever way to do this would be to bring this 0.5 to the other side and then use zeros. Then we can establish the domain, the constraints. And hit enter. Oh wait, forgot to put in the x. And now we can hit enter. Now we've got all the solutions in radians, and it is really easy to convert all of them into degrees by multiplying them by 180 over pi. And now we've got all the answers in degrees. And that's it for today's video. If you have any questions, please leave a comment. And if you enjoyed the video, please like or subscribe. Thanks for watching, and I'll catch you next time.